So here's the class opener, and if we focus in on this function right here, it's really easy to plug in 0. When I plug in 0 into the x spot, I'll have 2 to the 0. What's 2 to the 0? It's 1, and 1 times negative 3 is negative 3. So when we plug in the input 0, we get out a negative 3. Okay? If I plug in 1, let me rewrite it down here. If I plug in 1, it's going to be negative 3 times 2 to the 1. Now, if I do plug in that 1, what am I going to get as an output? Negative 6, correct? Okay. Now, I could keep doing this. I could continue plugging in values for x and getting answers, and those are my y values, my output values, and that'll give me all the coordinates that I need. However, there's something very important here, guys. The base tells you the pattern of your outputs if your inputs are in consecutive order. And I should also say that there is no h or k on this function. There is no h or k. Remember, h is the one that's with the x, and the k is the value out here by itself. When there's no h or k, you could quickly find your coordinates by looking at your base. Your base will tell you what's happening from one output to the next when you're looking at them in order. So what is the base on number 1? The base is 2. So what does that mean? That means that this first output of negative 3, if I multiply it by the base 2, it'll take me to the next one, negative 6. So what's the next output going to be? Negative 12. There you go, negative 12. And the next one? Negative 24. You guys see how easy that was instead of doing all the math with exponents and stuff? So instead of, if you wanted to, you could plug in 2 right here and say, okay, 2 squared, that's 4, and 4 times negative 3, yeah, that'll give me negative 12. But it's a lot easier to look at the base and recognize that that's the pattern on the outputs if these inputs are in order. If they're not in order, you can't use the base as a pattern. So it's that simple, guys. And let me also mention this. When you plug in 0, and there is no h or k, when you plug in 0, your output is always going to be simply your a value. When you plug in 0, right here, your output's always going to be simply the a value. And then from there, you could just look at your base and say, okay, negative 3 times 2 is negative 6, times 2 is negative 12, times 2 is negative 24. And you can find as many coordinates as your little heart desire. Okay, so let's go back. If I'm going times 2 this way and times 2 this way, times 2 backwards must be what? Dividing by 2, dividing by 2. Now, listen to this. Dividing by 2 is the same thing as multiplying by half. Isn't that right? 10 times 1/2 is the same thing as 10 divided by 2. So dividing by 2, you could think of it going backwards. Instead of dividing by 2, I could think of it as negative 3 times 1/2, and that'll give me negative 3/2, right? If I want to multiply negative 3/2 times 1/2, what's that going to give me? Negative 3/4. If I want to multiply negative 3/4 times 1/2, what is that going to give me? Negative 3/8. And you could get all the coordinates quickly without doing much math, without dealing with exponents or negative exponents or any of that stuff, right? Think about it. Let's go back up here, and let me actually plug in a negative 3 right here. If I did do that, let me plug in a negative 3. If I did plug in a negative 3, that's going to be 2 to the negative 3, and I also have the times negative 3 out here in the front. Now that means that this guy needs to be moved down, so I'd really have negative 3 up on top over 2 to the positive 3, which means negative 3 over 8. Now, I don't know about you guys, but that's a lot of math compared to just multiplying by 1/2. So right here, if you take this guy, multiply it by half, you get this guy. Multiplying by half, you get this guy. Multiplying it by half, you get this guy. Does that make sense? Makes sense to 2 people. Anybody else? Yeah. All right. Number 2. Let's take a look at that 0. Let's plug in 0 into here, and what do I get out? I get out the a value. What's the a value? 2. Okay? Now, I could plug in 1. I mean, let's do it. Let's plug in 1. 1 right there. What's 1/2 to the 1? And what's 1/2 times 2? That's 1, right? But you see, what you could do instead of doing that, right from this point, you could say, okay, my first answer was 2 because I plugged in 0, got out of 2. The base is telling me what? That I'm going to take half to get to the next number. So what's 2 times half? It's 1. What's the next number going to be? 1/2, because 1 times 1/2 is 1/2. Does that make sense? What's the next number going to be? 1/4, because 1/2 times 1/2 is 1/4. And what's the next number going to be? 1/8, because 1/4 times 1/2 is 1/8. Quickly getting these answers without doing much math. Going backwards, all right? If going in the numeric way, going down, it's multiplying by half. Going backwards would be what? Multiplying by what? The reciprocal of half, which is what? 2. So what would this next one be? 4. And this next one? 8. And the next one? 16. What do you guys think? Fun stuff, that's right. Number 3, let's plug in 0. What do we get when we plug in 0 for number 3? We get what? 2? Okay. Now, let's just use the pattern. What is the base telling me the pattern is going to be as I go this way? What do I need to do to the 2 to get to the next number here? Multiply it by what? By 3. The base is 3. We need to multiply it by 3. So 2 times 3 is? 6. And what's the next number going to be? 18, because the base is telling me multiply by 3. 6 times 3 is 18. And what's the next number going to be? 54, because 18 times 3 is 54. What's the next number going to be? 162. At the end of it all, to be honest with you, you don't even need any of these guys, especially if you have a 10 by 10 graph. 2 of 18 is already off the graph. But this is just to show you how easy it is to come up with all these coordinates. Now, if I was multiplying by 3 going this way, going backwards, it's going to be what? Dividing by 3. Or in other words, multiplying by the reciprocal of 3, which is 1/3. Now, it's really easy to multiply by the reciprocal of 3, which is 1/3. If you think about what's 2 times 1/3, that's really just 2 over 1 times 3, or 1 over 3, which is 2/3. Yes? Whoa. So 2 times 1/3 is 2/3. 2 times 1/3 is 2/3. How about 2/3 times 1/3? Imagine that. If I put times 1/3, what do I get out for the next one? 2/9. And how about for the last one? I want to multiply by 1/3. 2/27, right? Let me zoom in on that one. 2/27. Do you get it? And also, you actually don't need these guys either, because we know as we're going this way, it's approaching what? It's approaching 0. The numbers keep getting smaller and smaller. The fractions keep getting closer and closer to 0. As you go this way, it's going to positive infinity. So you can come up with coordinates very quickly, very easily. All right, so this next part of class is to copy down these notes that we have on the center board. But for the sake of the video, I'm going to pause it, let you guys copy it down, and then we're going to move on. Okay, so if you are at home watching this, you might want to pause and read this stuff over. But there is a big change. I noticed right now during third period that this is not X. Okay, scratch that out and put a B right there, because we should be talking about B the whole time, not X. So that should be a B right there. Okay? So if I were you, I would pause it, read this through, or read it through on your notes, and then we could move on to this part of the class, which is talking about growth functions and decay functions and being able to tell the difference when you're looking at them in a graph. So a growth function from left to right approaches either positive infinity or negative infinity. So right here on this one, let me zoom in a bit. On this one, from left to right, it's like not growing, and then all of a sudden it grows and it's growing to positive infinity. So what is that? Is that a growth or a decay function? Yeah. It's a growth function, right? So everybody label it as G. If we take a look at the next one, okay, it looks from left to right. We're not looking at it from right to left. We're going from left to right, kind of like when we read sentences from left to right. Right here, it looks like it's not going anywhere, and then all of a sudden, it goes down to to negative infinity. So remember, it says up here, a growth function from left to right approaches either positive infinity or negative infinity. So what is this, guys? That's also a growth. Now, if we take a look at this next one, a decay function from left to right decays, which means infinitely approaches but never actually touches a certain value like y equals a number. So this one, from left to right, you're way up here, and it's getting smaller, 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 and what does it do? It curves off, and it looks like it infinitely approaches a certain value, and that certain value is y equals 0. But nevertheless, the main understanding I want for you guys to have is that this is a decay function. It's approaching a certain value. It's not going to positive infinity or negative infinity. It's approaching a certain value, and that value is y equals 0, which is the asymptote. So this is a decay function with the asymptote 0. Let's move on to this next one. So what I would like you to do right now is, with the partner, discuss whether you believe this graph is a growth or a decay function and why. Go for it. That is correct. It is a decay function. You're way down here from left to right. It looks like it's growing, but it's not really growing. What it's doing is approaching a certain value. It's decaying to a certain value. That certain value is 0. So this is also a decay function. Okay. Let's move on to a couple more here. Everybody, is this a growth or a decay function? In other words, is it approaching a certain value or is it approaching infinity? It's approaching negative infinity, which makes it what? A growth. Okay? So from left to right, if it approaches a certain value, it's decaying to a certain value. From left to right, if it's going to infinity, whether it's positive or negative, it's growing to infinity, positive or negative. So how about this one right here? From left to right, what's it doing? It's decaying. It looks like it's growing, but it's not growing, guys. It's approaching a certain value. It's approaching the value of 4, the asymptote 4. So this is what we call a decay function. And of course, the asymptote is y equals 4, because that's where the line infinitely approaches but never touches. Let's check out this other one, the last two. Is this a growth or a decay? Decay, definitely. Why? Because from left to right, it approaches the value of 1. So the asymptote would be y equals 1. And the last one, is that a growth or a decay? It's a growth because it looks like it's right here at this value of -3, but then all of a sudden it grows to positive infinity. If it's growing either to positive infinity or negative infinity, it's a growth. We're going to have to do this on the test, guys. Now let's take a look at something even easier, which is comparing actual functions. Is this first one a growth or a decay? Why is it growth? Because the base is greater than 1. That's how we know it's a growth. How about this guy? Is this guy a growth or a decay? It's also a growth because the base is greater than 1. It's 1.5. How about this guy? Growth or decay? That's a decay because the base is less than 1. How about the next one? 6/5. That's a growth. How about this one? The 1/2 base. That's a decay. Is this making sense? How about this second to last one, 0.99? Is that a growth or decay? Decay. And last but not least, is that a growth or decay? Growth. That all comes from analyzing the base. If it's greater than 1, it's a growth. If it's less than 1, it's a decay.